This is Calculus AB 2016 AP Exam question number 1. This is Calculus AB 2016 AP Exam question number 3. Okay, they give us a graph here of f, and they say the figure above shown is a graph of a piecewise linear function from -4 to 12 of the function g is defined as the net signed area under the curve of f starting at 2. Okay, that's what this says here. Now, as soon as I see this kind of question, if you look at this, as soon as I see this, I know they want us to apply the fundamental theorem of calculus. It's a part of the fundamental theorem of calculus. And it says when g has relative max and mins, you need to know these ideas. When g has max and mins, that means g prime changes positive, negative, or negative, positive. If I want to know points of inflection on g, I need to know g double prime, and so forth. So I know I need to know g prime and g double prime. So I'm going to get into that right away. You don't have to do it this way. I'm just going to give you the whole thing with the sign lines. Okay, so let me just show you something right here. First of all, this is the fundamental part of the fundamental theorem of calculus. If I want to, if g, I'm giving you what they gave us right here. G is the definite integral from 2 to x of f of t dt. Okay, I'm just going to go through some steps here. You don't have to do all this. It's much easier than that. But if I was to integrate this, and if I said the integral of little f was big F, so the integral of this would be big F of t from 2 to x, okay? Which means I plug in x first, which would be equal to big F of x minus big F of 2, okay? Then if I was to differentiate g, that means I would differentiate these definite integral, okay? And therefore the derivative of a definite integral would mean this was the definite integral, so that means I need to differentiate this. So the derivative of big F would be back to little f, and it'll be little f of x. And since this is not a composition of functions, the derivative of this is simply f of x. And f of 2 is a constant, so the derivative of a constant is 0. So without going through all these motions here, g prime, the derivative of g, the derivative of an integral, by the way, you can sort of think of them as inverses. They're not pure inverses. But the derivative of an integral is like this just drops out. You get f of x. Okay? So g prime is equal to f of x. Then, so if I take the derivative of this side, this is what they gave us. If I take the derivative of g is derivative of g of g prime. The derivative of the integral is simply f. Okay? Then if I wanted the second derivative, or the second derivative of g double prime, would be the derivative of this, which would be g double prime, and the derivative of f is f prime. Okay? Now the whole key here is I get all my information from f, from the graph, and then all the questions are asking me about g. I need to know these connections. Okay? So you really need to write this down. You need to write down what g prime is equal to, what g double prime is equal to. I'm going to draw the sign lines. Okay, this is where the graphs are positive and negative, or slopes are positive and negative from f, and I will use these sign lines to answer all my questions about g. Okay, so let's just see how they go. So g prime is equal to f. So this is a graph of f. So it's pretty easy to see that f is 0 at -2, 2, 6, and 10. So f is equal to 0 at -2, 2, 6, and 10. Those are zeros. Okay. And you can see then that the graph is below the x-axis. This is the graph of f. It's negative. So between -4 and -2, it's negative. Then here it's positive and positive. So it's really positive all the way up to 6, except for 2 where it's 0. So it's positive. And then the rest of the time it's negative unless it's 0 here at 10. Okay, so that is this is the sign line for f, which is the sign line for g prime. Okay. And now if I want to know f prime is the slope of this, so I need to find where it's undefined or 0. So the slope, remember these are corner points, so the slope is undefined at this point, which is 0. It's undefined at 2, undefined at 4, undefined at 8, undefined at 10. So this f prime, the slope of this graph, is undefined at 0, 2, 4, 8, and 10. 0, 2, 4, 8, and 10. Okay, all corner points. Okay, now the slope of f is positive up to 0, so the slope is positive. Then the slope goes negative up to 2, so slope is negative. Slope is positive again. Slope is negative all the way up to 8. Slope is positive to 10. Slope is negative. Okay, so there's my sine lines. So that's very simple, very straightforward. I mean, if you realize you need these sine lines, you can do them all at once. I'm going to do them step for step, but I'm just going to copy these sine lines onto the next pages. So let's start answering the questions. So here's the first question. It says, does G have a relative maximum, or relative minimum, or neither at x equals 10, and justify your answer. So over here at x equals 10, now remember, I got all my information from the graph of f. When I talk about G, I'm not going to get confused and talk about f. There's my connection. So when does G have a max minimum? It depends upon whether G prime goes from positive to negative, or negative to positive, or neither. So you see at x equals 10, G prime, this is G prime, it's negative before, it's negative after, which means there is no relative max or min there. Okay, so G prime has neither relative max nor relative min at x equals 10 because G prime does not change sign. And that's your justification. G prime does not change sign. Now what I did here, just to kind of help you out a little bit, I did a rough graph of G, really crude, okay? But let's see what happens. If G prime, that means G. This is the graph of G now. Remember, this is the graph of F. This is the graph of G. G prime is negative, which means the graph is coming down to negative 2. Then from negative 2 to 2, it's going up because G prime slope is positive. So it's going up, and then it's 0, slope is 0. Then it goes up again. So it goes back up again to 6. And now the slope is 0 at 6. Now it starts to go down to 10. Slope is 0 at 10. Then it goes down again. Okay, so you can see here at 10, the graph is going negative. It goes to 0, and it goes negative again. So there is no relative max or min. Here there's a relative maximum at 6 because G prime changes from positive to negative. Here at negative 2 there's a relative min because G prime changes from negative to positive. But over here there's neither a relative max or min either because the slope was positive and then positive. Okay, that may help you see that a little bit. But all you need to do is do what I just did here for your answer. Remember again, I'm doing a lot of extra work here. Okay, here's a sine line for G double prime, which is equal to F prime. I just copied that from the first page. Okay, and a point of inflection is when G double prime changes sign. So in order to have a point of inflection, G double prime must change sign. And so this says, does G have a point of inflection at x equals 4? Justify your answer. So here's x equals 4. Okay, so G double prime, this is the graph, it goes from positive to negative. Therefore, there is a point of inflection. As a matter of fact, if you look at this, there's all kinds of points of inflection. There's a point of inflection at 0 because G double prime changes from positive to negative. There's a point of inflection at x equals 2, changes from negative to positive. At 4, positive to negative. At 8, negative to positive. At 10, positive to negative. So you only have to answer the question, though. Don't give extra information. At x equals 4, there is a point of inflection because G double prime changes sign. Now let's look at that little graph I showed you a minute ago. When G double prime is positive, that means it's concave up. So it's concave up to 0. See, up to 0, it's concave up. Then from 0 to 2, it's G double prime is negative, so it's concave down. And then from 2 to 4, it's concave up. And then from 4 to 8, it is concave down. Okay, then from 8 to 10, it is concave up. And then from 10 to 12, it is concave down. And remember, it's sort of hard to tell sometimes with concavity, but if you draw a tangent line to the curve, okay, in other words, if I drew a tangent line here, the tangent line is above the curve, therefore the curve is concave down. When it is concave up, even though it's hard to tell, in this region right here, it's concave. If I drew a tangent line, you would see that it is below, therefore it's concave up. Okay, that might be a little helpful hint there. Okay, let's look at part C. Part C wants to know, find the absolute minimum value and the absolute maximum value of g on the integral from -4 to 12 and justify your answers. Now remember, absolute extremer are located on g, are located either endpoints or critical points. That's where they are. Okay, so what we want to do then is we want to find the critical points. Remember, critical points are when g prime is 0 or undefined. So g prime is 0 at -2, 2, 6, and 10. Okay, it's never undefined, so that's not a problem. Now, so the critical points are -2, 2, 6, and 10. Now, actually, you don't have to list them all because this is a relative min. Could be an absolute min, but it is a relative. This is a relative max at 6. And remember, at g of 2, it's going up and then it goes up again. So this is neither a relative min or max. And over here at 10, it's neither a relative min or max. Therefore, you don't really have to include them. It doesn't hurt to just put them down and say neither relative min or max. Okay? So here's the critical points at g of 2 and g of 6. They're the key critical points. And these are the endpoints, g of -4 and g of 12. Now, how do we get these? Well, here's what they gave us. They gave us g of x was equal to the definite integral from 2 to x of f of t dt. So if we want g of -4, we plug -4 in for x, plug -4 in for x, plug -4 in for x. So that means it's the integral from 2 to -4. Okay. Now, you got to be very careful. When we're integrating, definite integral is a net signed area, so it can be either positive or negative. So let's just get a little groundwork here. If I'm starting at 2, if I'm moving to you don't have to memorize this stuff. If I'm moving to the right, I'm going in the positive direction. Therefore, that's plus. And the curve here is above the x-axis. It's in the positive side. So that's plus. So a plus times a plus is a plus. Okay? So the net signed area of this would be positive. If I'm still moving in this direction, and so I'm moving in the positive direction, so that's plus, but the curve is below, that's minus, so a plus times a minus is a minus. That's all. Now, if I'm going backwards, if I go 2 this way, if I'm integrating from 2 this way, that means I'm going in the negative direction, so this is negative. The curve is above, so that's positive, so a negative times a positive is a negative. So the net signed area would be negative. And of this last region, if I'm going this way, I'm integrating in the negative direction, and the curve is below, which is negative. A negative times a negative is a positive. So the net signed area of this would be positive. Okay, so let's see. So the integral from 2 to -4, definite integral from 2 to -4, is going to be, so I'm going this way, so that's going to be, it's going to go negative, negative, negative. So over here, it's going to be -8. And then it's going to start becoming, these numbers are going to be positive, but I have -8, and the biggest thing I'm going to do is add 4, so it's going to end up over here at -4. So the integral from 2 to -4, the net signed area under this curve is -4. Hopefully you understand that the integral from 2 to 2, the integral from 2 to 2 is 0. Okay, if the thickness of this is 0, then obviously the area is 0. Okay, if I want the other endpoint, g of 12, that means I'm starting at 2. I'm going to integrate to 12. So I'm going in this direction. So as I'm moving along, this is +8 over here. And now all these are negatives, but all of a sudden, when I get to here, so I have +8 and then a -8. So I'm back to 0. And now the rest of this is -4. So that the integral from 2 to 12 is -4. Not hard to do, and you just be careful with this and you don't make any mistakes. Okay. If I want now the integral from 2 to -2, that's this critical point here. So 2 to -2, this is negative, that was positive, so this is going to be a -8. And the integral from 2 to 6, this is positive, that's positive, so this is 8. Okay, so now you just look at the critical points and endpoints and look at the values. So -4, -4, -8, that's lower. That's the lowest, and 8 is the highest. That's the max. So this is the absolute max. This is the absolute min. So there's an absolute min of -8 at x equals -2, and there's an absolute max of 8 at x equals 6. Okay. This last part says on this whole interval from -4 to 12, it says find all intervals for which g of x is less than or equal to 0. So we want to know where g of x is negative or equal to 0. That means, remember, g of x is equal to the definite integral from 2 to x. So see this net signed area under this curve here, okay? So if I'm going to start at 2, so let's see, we want to know where it's negative. So if I start at 2 and I go this way, as soon as I start off, the net signed area is negative because this is negative, the curve is positive. So negative times a positive is a negative. So it's going to be negative all the way along. So it'll be -8 here, okay? And then in this region here, even though I'm starting to add these values, because negative and a positive is a negative, so negative and negative is a positive, so therefore I'm at -8, and then I'm going to end up -4. But all the area here is going to be negative. So the net signed area from 2 all the way over to -4 is negative. It's negative all the way across here. It's -8, and then it will end up being -4. So it's negative from -4 to 2. This whole region is negative. Now when I start here, when I start going this way, right away the net signed area is positive because this is negative, and I'm going in the positive direction, so it's positive. Curve is above, it's positive, so the net signed area is positive. Okay, then this is going to start to deduct from that 8, but it's only going to get down, it's at 0 here. And now when I'm going this direction, this is positive, the curve is negative, so I'm going to get negative. So it's going to be negative from 10 to 12. And you make sure you put your equals on there because it says less than or equal to 0. It is equal to 0 at -4. Well, it's negative there. It's equal to 0 at 2, and it's equal to 0 at 10 and 10. Okay? Let's see what they gave you the points for. Very important, they gave you this point here to show the connection. This is the fundamental theorem of calculus. So G prime is equal to F. Okay, and then the answers with justification. Now again, they don't show you the sign lines. Just a point, you do not get credit for the sign lines, but the sign lines are very powerful to help you answer the questions. So you can't say, look at the sign line. That's not, you need to say. So you need to say that the function has neither a relative minimum nor a relative maximum at x equals 10. Since g prime, you don't have to keep connecting this as long as you have this written down where it's visible. So as long as you say g prime, they say on this whole interval, f is less than or equal to 0 on this whole interval. Okay, so you really just have to say g prime, there's neither relative max minimum because g prime doesn't change sign. Is what I think that's it. Okay. And I don't like the way they use, they're asking questions about g and they're answering with f. To me, that's very confusing. When f is less than 0, that means g prime is less than 0 on this whole interval. Okay, so basically g prime is negative, or g prime goes from negative to negative. Okay, this here answer with justification, point of inflection at x equals 4, since g prime, again, they use g prime as increasing. I use g double prime because if g prime is increasing, that means g double prime is positive. And in this region here, in this interval here, if g prime is decreasing, that means g double prime is negative. So g double prime goes from positive to negative is where there's a point of inflection. Okay. For the absolute max and mins, again, they showed the critical points. Remember I mentioned you only need to put the 2 critical points because the other 2 are neither relative max or mins. So you need to consider those 2 as candidates. Okay, you need to consider the endpoints. And then, excuse me, if you put all the values down, I didn't do it this way. I did f of g of -4 and so forth. And then if you just look, the minimum is right there, -8. The maximum is 8. So on the interval, the absolute minimum, they give you those. That's what you get your points for, and it's for justification. And this one here, you get 2 points for the intervals. So g of x is less than or equal to 0 when x is between -4 or inclusive to 2, and x is between and inclusive 10 and 12. Okay?